about fractions, addition, and subtraction. This is part 1 of the series, and let's get into it. Our first question is 5/8 plus 3/8. So we can imagine this like a pizza. So 5/8, we could put a pizza with 8 slices. So I'm going to shape 5 of these slices. So this 5/8 plus 3/8. So we can imagine my friend is giving me 3/8 of a pizza because I'm hungry. And so we could put an addition sign. And again, our denominator is 8. So it's an 8-slice pizza. And he's giving me 3 slices from an 8-slice pizza. So this pizza is again 8 slices. I'm going to number once again. So 3 slices. He's going to give me 3 slices. Our denominator is 8. We have 8 slices in our pizza. And I'm going to shape 3 slices of our pizza. So 5 slices plus 3 slices in an 8-slice pizza. So this is the same as saying, we have the same denominator. So it's the same as saying 5 plus 3, 5 slices plus 3 slices, 5 plus 3 with the same denominator of 8. 5 plus 3 over 8. So now all we have to do is add it. So 5 plus 3 equals 8, and our denominator is 8, because 8 slices. 8 slices of pizza over 8 slices. A common mistake that people do is that they add the denominator. You shouldn't do that because that will change your answer completely. The denominator always stays the same in an addition or subtraction problem. Always keep that in mind when you're doing math with fractions. So here we have 8 slices over an 8-slice pizza. This is the same as saying 8 divided by 8. 8 slices in an 8-slice pizza, that's one whole pizza. So our answer is 1. Question 2. Again, our denominator is 13. So we can imagine this like a chocolate bar. A 13-piece chocolate bar. Again, because our denominator is 13. So we have 5 pieces in our 13-piece chocolate bar. So 1, 2, 3, 4, 5. And the total is 13. There's all this that is gone. We don't have it. We ate it. And my friend is gonna give me, again, 9 more pieces. Because, again, I'm hungry. So we're gonna put a plus sign and 9 pieces of chocolate. 1 and 9. And this again is gone. He ate the other portion of chocolate. So 5 pieces of chocolate plus the 9 pieces of chocolate that he's giving me, we're adding that into, we can just add 13. It's 13 for both of them, so the denominator is 13 for both of them. That means 5 and 9 is just left to put. So 5 plus 9, 5 pieces of chocolate, my 5 pieces of chocolate, plus his 9 pieces of chocolate is 5 plus 9. 5 plus 9 over 13. Now that's left is just adding. So 5 plus 9 is 14 over our denominator is 13. We put the 13. We don't add the denominator again. So our answer equals 14 over 13. Now this is an improper fraction. We can still reduce it. 14 over 13. How many 13s go into 14? It's 1. So we have 1. 1 chocolate, full chocolate bar can go into 14. So what's left? 1/13, right? So 1/13 just goes beside the 1. 1 and 1/13 is the answer. 5/13 plus 9/13 equals 1 and 1/13. I hope you understand this part, And we'll move on to the next question. Question 3 is 2 and 2/5. Now we have a mixed number plus 1/5. So this is a different type of question now. We both have the same denominator, but we have a whole number in front of one of them. So for this, it's also simple. We can forget about our 2 right now. We don't even need to think about the 2 right now. So all we need to look at is 2/5 plus 1/5. So 2/5 plus 1/5. Both of the denominator is 5, so it's a denominator of 5 and 2 plus 1. That is 3/5. So we can put our 3/5 over here, and all we have to do now is put the 2 back here. Now, there's a different way of doing this that will give you the same answer. So you see our 2 and 2/5 over here? All we have to do is we're going to multiply this and add this. The denominator multiplied by the whole number added by the fraction. So why do we do this? This gives us an improper fraction. 2 is the same as saying 5/5 plus 5/5. And now we have a 2/5, right? That's the same as saying plus 2/5. 5/5 plus 5/5 plus 2/5. Now, when it's a mixed fraction, the easier way of doing it is just multiplying the denominator by the whole number and adding the numerator. So when we do this, we get, so 5 times 2 is 10. 10 plus 2 is 12. 12/5. Now we'll say this is also a chocolate bar. 2 whole chocolate bars, 1 chocolate bar, 2 chocolate bars, at 2/5 of a chocolate bar. So 1, 2. We could divide these into 5 because each chocolate has a denominator of 5. So each chocolate is a 5-piece chocolate bar. So we have 2 chocolate bars and 2 pieces of a 5 chocolate bar. So now we're gonna add 1 piece of chocolate. So again, my friend is so nice. He gives me so much things. He gives me another piece of chocolate, of his chocolate bar. His chocolate bar is also a chocolate bar of 5, with a denominator of 5. So he gives me 1 piece of chocolate from his 5 pieces of chocolate bar. So we already found out what this whole thing is worth. This whole thing is worth 12 pieces of chocolate. If you don't believe me, you can count it out. There's 5, and then there's 10, and there's 11, and there's 12. 12 pieces over a 5-piece chocolate bar. And he's giving me 1 more piece. 1 piece of a 5-piece chocolate bar. So we write plus 1/5. Now we have the same denominator, right? So that equals a denominator of 5. So 12 plus 1/5, because the denominator is 5. It's a 5-piece chocolate bar, again. And he's giving me a piece of chocolate. 12 plus 1/5. Now that equals 13/5. Now we use the same type of steps that we did in this. So now, the previous one. Now, how many 5s go into 13? 2. 2 5s go into 13. 2 5s, 10. 10 goes into 13. So 2 can go into 13. 2 5s can go into 13. Now what's left? 3 is left. 3 is left of the chocolate bar. 3 pieces of chocolate is left from our total. Now that we added this, it's now 3 pieces of chocolate. 2 chocolate bars and 3 pieces of chocolate. So 3 pieces out of a 5-piece chocolate bar, that's 3/5. Our answer is 2 3/5. I hope you understand this part, and we'll move on to the next question. Question 4. 2 2/9 plus 4 and 5 ninths. Wow, now we have two mixed numbers. We're adding two mixed numbers together to find a whole sum. So 9 pieces, there's 2, 4, and there's fraction. So 2 chocolate bars, and there's 2 ninths of a chocolate. So that means each chocolate bar is worth 9 over 9. So let's keep that in mind. So that means each chocolate bar is divided into 9 pieces. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. That's a whole chocolate bar. 9 pieces, a 9-piece chocolate bar. So we have 2 of these. That means we have 2 chocolate bars with 9 pieces. 1, 2, 3, 4, 5, 6, 7, 8, and 9. That 2 chocolate bars plus 2 ninths of a chocolate bar. 2 more pieces from the chocolate bar. So now we have 2 and 2 ninths of a chocolate bar. Again, we can think of this like a dotted line. And yeah, this is the chocolate bar that's missing. We ate it. Now, my friend keeps on giving me so many things. He gives me 4 chocolate bars and 5 ninths of a chocolate bar. 5 more pieces after the 4 chocolate bars. So plus 4 chocolate bars, each divided into 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 4 chocolate bars, he gives me 4 chocolate bars and 5 ninths of a chocolate bar. So what we could do, we could just put 5 more pieces.
1, 2, 3, 4,
and 5. Now we can write the dotted line. He ate those chocolates and he's generous enough to give me the rest. So now all we had to find is what it's equal to. So for this part, what we could do is we could add the whole numbers first, and then add the fractions first. This makes this easier for us, and yeah. So 2 plus 4, we can add our whole chocolate bars together, and then add our fractions together to give us the answer more easier than to borrow. So 2 chocolate bars plus 4 chocolate bars, that equals 6 chocolate bars. 6 chocolate bars, and now we have to add 2 ninths and 5 ninths. So 2 ninths and 5 ninths, we both have the same denominator, 9 and 9. We both have 9-piece chocolate bars. He bought 9-piece chocolate bars, and I bought 9-piece chocolate bars. So each chocolate bar has 9 pieces of chocolate. So our denominator is 9. So 9, and it's 2 plus 5. We forget about the mixed numbers because we already added them. So 2 plus 5, let's write that down. 2 plus 5, 2 pieces of chocolate plus another 5 pieces of chocolate over our denominator of a 9-piece chocolate bar. So 2 plus 5 over 9. Now 2 plus 5 is 7, and our denominator stays the same. 6 and 7 ninths. 2 and 2 ninths plus 4 and 5 ninths equals 6 and 7 ninths. I hope you understand this question, and we'll move on to the next one. 3 and 7 elevenths minus 1 and 2 elevenths. So this is starting to get more and more different. Now we have a subtraction. Now we're gonna subtract it. So 3 and 7 elevenths. Now, because my friend is being so nice and giving me all these things, I have to give him something in return. I'm giving him 1 and 2 elevenths of, let's say, another chocolate bar. So I have 3 and 7 elevenths. I bought 3 chocolate bars, each with 11 pieces, and 11. And I bought 3 of those, so I'm gonna make 3 bars in the same size. 10, 11. And Now I have 3 chocolate bars and 7/11ths of a chocolate bar. So 7 more pieces are added to those 11-piece chocolate bars. 7 pieces and 3 chocolate bars. We can put the dotted line again over here to just help us remember that that is eaten. Now, this is the amount I'm going to give chocolate to my friend. So, now we have a subtraction sign. Minus 1 and 2/11ths. 1 chocolate bar, 10/11, and 2 more pieces. And again, we can write our dotted line. So, this is the amount I'm giving him. This is 3 and 7/11ths. And this is 1 and 2/11ths. Now, again, we're working with the same denominator. But first, let's do the mixed number portion, the whole number portion. So 3 minus 1, 2. 2 pieces, 2 chocolate bars. 2 whole chocolate bars I'm giving him. Now we're going to go to the fraction portion. 2 whole chocolate bars that I still have. So now 5/11ths minus 2/11ths, and 7/11ths minus 2. So our denominator is still 11. So 11 is our denominator. 7 minus 2. 7 minus 2. 2. So all we have to do is do 7 minus 2 now. So 7 minus 2 is 5, and our denominator always stays the same. 7 minus 2, 5/11ths. This is our answer after I give him the 1 and 2/11ths of the chocolate bar. So we can think of it like this. I have 3 chocolate bars and 7/11ths, and I'm giving him 1 and 2/11ths, and this is what I have left. 3 7/11ths minus 1 and 2/11ths equals 2 and 5/11ths. I hope you understand this question, and we'll move on to the next one. A whole number minus a mixed fraction. We can again imagine it like our chocolate bars. Our chocolate bars are like the easiest way to picture these and visualize. Question 6. So we have 3 chocolate bars. 3 whole big chocolate bars. And they're completely full because it's a whole number. And our fraction is our other part is 5. That means we should divide our whole number into 5s. So it's 3 equals 5/5 plus 5/5 plus 5/5. So each of these are 5 pieces of chocolate in a 5-piece bar. So 1, 2, 3, 4, 5. 4 and 5. I have 3 whole chocolate bars. And my friend keeps on giving me so many things, I have to return something to him. So I'm giving him 2 and 2/5 of a chocolate bar. So we're subtracting, so there's a minus sign. Minus 2 and 2/5. 2 chocolate bars, I'm subtracting 2 chocolate bars. I'm gonna give him 2 chocolate bars of my 2 chocolate bars and 2/5. So we're gonna again divide our chocolate bar into 5. And 2/5 are left. So 1 piece of chocolate and 2 pieces of chocolate. 2 and 2/5. We can draw our dotted line as this is what's gone. I'm gonna keep that for myself. So 3 chocolate bars minus 2 and 2/5 of a chocolate bar. Now all we have to do, we can imagine this as this, right? So this is the same, 3 is the same as saying 15 over 5. 5 plus 5 plus 5. Our denominator always stays the same. Our denominator is 5. Now we might subtract the mixed number. So 5 times 2 plus 2. 5 times 2 is 10. 10 plus 2 is a 12. And 12 always stays on it. The denominator always stays the same. Minus 5. And our denominator is 12. We're subtracting. Our denominator is 5. So what we could do is we could write, this is the same as saying 15 minus 12 over 5. So now all we have to do is do the question. So 15 minus 12 is 3. And our denominator is 5. So we just keep our denominator the same. 3 and 3 over 5. Now another way of doing this, as I said before, you know the whole numbers, we could just subtract the whole numbers and then keep that. So 3 minus 2, so this is our second method. So I'm going to write a squiggly line. So 3 minus 2, 3 minus 2, 2/5 equals. So 3 minus 2 is 1. And now we have to do this part. Now we still have 1. The question is basically saying 1 minus 2/5, right? And as I showed over here, 1 is equal to 5 over 5 because our chocolate bars are divided into 5. Each 5 pieces, 1 is equal to 5 over 5. So how we can write this is 5 over 5 minus 2 over 5. And all we have to, our denominator is the same, right? So we put equal over 5, 5 minus 2 over 5. Now all we have to do is subtract it. So that equals 3 over 5. 5 minus 2, 3. Our denominator always stays the same. I'm emphasizing that the denominator always stays the same so that you can remember it. You need to know that the denominator always stays the same. You could do all of this right and add the denominator, and the whole answer will change. Always keep the denominator the same. Okay guys, the video has come to an end. I hope you enjoyed this video. If you like our content, please subscribe. If you have any doubts, please leave it in the comment section. And I'll see you in part 2. Bye!